Good morning everybody. In this lecture we are going to see the problems on the order of reaction. So the first problem, for a certain reaction when the initial concentration of the reactant doubles, the half-life period becomes half of the initial half-life. Determine the order of reaction. See what is given here. When the initial concentration of the reactant doubles, let's consider that in the first reaction the concentration is A1, in the second reaction that we are doing the initial concentration is A2. Now what the condition is given? The initial concentration of the reactant doubles. That means while carrying out second reaction the concentration is doubled. That means that if in a first reaction the concentration is A1, the concentration in the second reaction initial concentration is A2, it is equal to twice of A1. This is what is the condition we have given related to the initial concentrations. Now the condition which is given related with the half-life is half-life period becomes half. Let's consider that T half 1 is the half-life for the first set of reaction and T half 2 is the half-life in second set of reaction. The half-life period becomes half of the initial half-life. That means this half-life becomes half of this initial. That means T half 2 is equal to T half 1 divided by 2. This is what is the condition we have given, and we have asked to determine the order of reaction. Now the formula to determine the order of reaction from the T halves is 1 plus log of T half 1 divided by T half 2 divided by log of A2 divided by A1. This is what is the formula. Therefore, let's substitute the values. N is equal to 1 plus. Now, log of T half 1 divided by, now T half 2 is equal to T half 1 divided by 2 divided by log of, now what is A2? A2 is nothing but twice of A1 divided by A1. So therefore N is equal to 1 plus, now T half 1 get cancelled, therefore log of, now this is 1 upon 2, so this will be log of 2, 1 divided by 1 by 2, this is like this. So it will be 1 into 2 divided by 1. That means this is log of 2 divided by, again this get cancelled, so log of 2. So log of 2 get cancelled. N is equal to 1 plus 1. So order of the reaction is nothing but 2. Now the next problem we will see. For this reaction here, the second problem is determine the order of reaction for decomposition of ammonia on tungsten wire. The half-life period of reaction is 50 minutes. So let's consider T half 1 is 50 minutes at 0.1 molar concentration of ammonia. So A1 given is 0.1 molar. When concentration of ammonia is reduced to half, so this is the first set. Now in the second set what is done? The concentration of ammonia is reduced to half of the initial. So A2 is equal to A1 divided by 2, that means 0.1 divided by 2, 0.05 molar. This is the concentration in the second set. When the concentration of ammonia is reduced to half of the initial concentration, the half-life period is 25 minutes. That means the value for T half 2 is 25 minutes. So these are the values we have given. Therefore, again the formula, order n is equal to 1 plus log of T half 1 minus log of T half 2. You can write the formula in this way also. So log of A2 minus log of A1. This is equal to, now let's put the values. N is equal to 1 plus. Now what is the T half 1? It is 50. So log of 50 minus log of, what is T half 2? 25 minutes. So log of 25 divided by log of A2. What is A2? 0.05 minus log of A1, that is 0.01. So this is equal to, N is equal to 1 plus. Now you can write this as, see, here the subtraction between the logarithm is there, so you can write them in a quotient also, like this, divided by log of 0.05, like the way in first problem we had written. This is 0.1, not 0.1, 0.1. So N is equal to 1 plus, now this is log of 2 and divided by log of log of 1 by 2. So this is equal to 1 plus log of 2 is 0.3010 divided by log of half, that means log of 0.5, and the log of 0.5 0 minus 0.3010. So this is equal to this cut, so minus 1 remains, so 1 minus 1, 0. So the order of the reaction for the decomposition of ammonia on tungsten wire is nothing but 0. Next problem. For the gaseous reaction of hydrogen iodide, the reaction given, the reaction is this is what is the reaction we have given. For this reaction, the half-life periods are 40 hours and 10 hours. When the initial concentration of hydrogen iodide are 5 moles per liter and 20 moles per liter. So determine the order of this reaction. See, here we are seeing that two molecules are being used in the reaction, stoichiometric balanced reaction. We can see that two molecules are there. Let's see whether the reaction is having the order 2 or not. Here we are given the conditions of T half and the initial concentration. So these are the values. Let's directly write them with the symbols. T half 1 is equal to 40 hours and A1, the initial concentration in the first set is 5 moles per liter. Now T half 2 is 10 hours and the value for A2 given is 20 moles per liter. So these are the values we have given and we have asked to calculate the order of the reaction here. So let's first write the formula and then we will substitute the values. Let's write the formula here. 1 plus log of t half 1 minus log of t half 2. We can write this as log of directly t half 1 divided by t half 2 divided by log of a2 by a1. So let's substitute the values. N is equal to 1 plus log of t half 1 is 40, t half 2 is 10 divided by log of a2 is 5 and a1 is 20. Sorry, this is 20 and a2 and a1. 40 divided by 10, correct. So 1 plus log of obviously 4. This is also 4. So log of 4 divided by log of 4, that means 1 plus 1. So the order of this reaction here is nothing but 2 here. For the decomposition of tungsten, decomposition of ammonia on a tungsten wire, here that reaction, second problem that we had seen, that reaction is ammonia, which gives this is what is the reaction. Now in this reaction, the order of the reaction is 0. What it means? This means that the concentration of ammonia does not affect the rate of the reaction. That means the rate of reaction does not depend on the concentration of ammonia which is present in the reaction. Next time we will see some more problems.